Hello out there to you. In this video, we're going to do a monopoly practice problem. I'm going to do this one algebraically, but you could also do it graphically. And just as a test, I punched it into a chat bot and I didn't get the right answer. I was surprised by that. And so if I had gotten instantly the right answer, I wouldn't be doing this video. So it's good, I guess, to get the human touch. Okay, so we've got this monopoly for a product. The product doesn't really matter, but it's grapes to make wine, yum. We've got a demand function right here. This is actually an inverse demand function. We've got a marginal cost function, total cost function. The only reason we need that is so that we can derive the marginal cost function, but that's already done. And it says, remember that you can find marginal revenue as a function of Q just from the demand curve. So what that means is that MR is really whatever your demand function is. And then if you multiply that by 2 on a linear demand function, you get the marginal revenue. So it's like a trick that you can use. So it's be 1200 minus, it's 0.1 times 2, so that turns it into 0.2Q. In some of my other videos, I've got the derivative practice on how to get that. But in this problem, we're just going to use the trick. So we've got that. All right, if they can't price discriminate, it means we have to charge a single price. So it says find the profit maximizing quantity of grapes that we can choose to produce and what price it is. So we're going to set, to do that, we're going to set marginal revenue equal to marginal cost and then find Q. Okay, that gives us Q star. And so to do that, it would be 1200 minus 0.2Q equals 0.1Q. Okay, and this would be pretty easy to calculate. So 0.3Q equals 1200. And then Q kind of ran out of space here. Q would equal 1200 over 0.3, which I do not know off the top of my head. So 1200 over 0.3, 4,000. So quantity would be 4,000. So that's the quantity that we're going to produce. Then we plug, what you do next is plug Q star back into your demand function. And that's going to give you the price. It's like we're marking up the price. So price then would be 1200 minus 4,000 times 0.1. So that would be 800. We solve for that. So the answer there, quantity, and we're calling it Q star, excellent, is 4,000 and price is 800. Okay, so okay, now we can not price discriminate. How much profit do they earn? So profit is going to be over here, and that's total revenue minus total cost. So we can actually just plug in the quantity into that cost function. That's kind of nice, and that'll give us our total cost, and then total revenue is price times quantity. So that would be 32, and then we're going to tack on some zeros. 1, 2, 3, 1, 2. I like to put some commas there. 3.2 million, so kind of a big number. That's our total revenue, and then our total cost. That one I need a calculator for. So it's going to be 4,000 squared, 16 million times 0.05. Whoops. 0.05. Okay, 800,000. Okay, so that would be 2.4 million. Okay, so 2.4 million. Are we doing dollars in this one? No, it doesn't say. Whatever the units of currency, the rupees, whatever. C. Suppose the monopolist engages in first-degree price discrimination. Okay, we got to know what that means. What it means is everybody's going to pay their spot on the demand curve. So you're going to find wherever MC equals demand, and then everybody's going to pay exactly what their price is all the way on that demand curve. So what we do to find that, let's get a good green here. We want to know where demand equals marginal cost, and that's going to give us the quantity. So that's the only thing we're solving for here. So 1200 minus 0.1 Q equals 0.1 Q. So then this would be 0.2 Q, 1200. And then Q is, I don't know, you probably know that. 12,000 over 0.2, 6,000. So 6,000 units. And that makes sense that it would be more than if you were charging a single price, because a single price monopoly is going to find where it's MR equals MC right here. So it cuts back and it causes some deadweight loss. But with perfect price discrimination or first degree price discrimination, those are synonyms on different classes, then they're going to produce out to this allocatively efficient level. Okay, how much profit do they earn? Okay, so for this, you kind of want like the triangle. Okay, so let me think about that one for our profit. Okay, so again, we have total cost is actually the same. So our total, well, no, it's not the same. It's more. Total cost is actually going to be 0.05 times Q squared, but on 6,000. So let's find out what the total cost is. So 6,000 squared, and then 0.05 is 1.8 million. So okay. So total cost is that, and then we want to know what the profit is. So it's like the triangle that is right here. So it's like everybody. It's the last. It's the last unit there. So this is 6,000. So if I'm doing the triangle here, I need to find out what the top of the triangle is and then what this is right here. So to get this number, I'm going to plug 6,000 into the demand function, and that'll give me this part of the triangle. Okay, so 6,000. So that would be, what is that price? It would be 1,200 minus 0.1 times 6,000. I think I can do this in my head. That would be 600. That would be price is also 600. So that's right here. That's 600 is that one. Then I want to know what this is. So this is where quantity is 0. So this would be 1,200. Okay. So the formula would be this 600 times 6,000, and then it's a linear triangle, so it's half of that. So total revenue is 1/2 600, this is in dollars, times 6,000, and it's some big number, 6,000 times 600, 3.6 million. Half of that is going to be so that's part of the revenue. Then I want this bottom part right here. Okay, so on that, then it would be 600 times 6,000. So then it's another 3.6 million. So 3, 6. Okay, so 1.8 million plus 3.6 million. Actually, that could have just canceled out, I guess. So that's our total revenue. Our total revenue is 5.4 million. 5.4 million minus 1.8 million, and that gives us our profit, which is 3.6 million. And that's how to solve for that. So just to recap that last part, what you do is you want to find, for total revenue, you want to find the triangle part and then add it to the rectangle part because it's capturing this entire area there. And that's how to solve that type of problem, monopoly problem, from usually a managerial economics class.